can we draw? We take a section at the end, either A or B. Anywhere we can get, we can take the section. We in this question, to solve this problem, to draw this shear force diagram, we take the section at B. At section B. Then section, the left side of this section, force left side of this section will be taken as negative. Section is at B, so RA will be negative. How much? W by 2. So we come down by W by 2. Then there is no any load between A to C, so it will be parallel to this zero line AB. It will go parallel to AB line, zero line, because there is no any load between A and C. We have reached at point C. Here C is having load W downward. The load left side of section, if upward we will take negative, if downward we will take positive. So now from this point we will go upward by W. So here W by 2 distance covered, here W by 2, and because C having W load, so we will go above this zero line by W by 2 again. So we reached at here this point. Now there is no load between C and B, so the line will be parallel to this zero line AB up to C. Then the section at B and RB is left side of section. RB is taking left side of section, and so we will, this the value of RB is negative, so from B we will come downward by value of RB, and RB is W by 2. So we come down from this point B by W by 2, we reach at point B at zero level line. So this is shear force diagram. I hope you have understood all these values, sign convention and diagram. Now we go ahead to calculate bending moment diagram. Bending moment diagram. Moment at A is, because this is simply supported beam, so supports are roller or hinge, moment is 0. So MA is equal to 0, MB is equal to 0. Then we take the section at E. We take the section at E. That means we want to calculate the moment at E. Moment at E, section left side of this section E, there is RA force reaction, then RA multiplied by distance from A to E, that is L by 4. Direction clockwise, section, if any moment having the clockwise direction, left side of this section will be taken as negative. So this is negative RA into L by 4. Then this comes to minus WL by 4. So moment at E is minus WL by 8. Now we calculate the value of moment at C. So we take the section at C. Then between A and C there is no load, only a reaction RA is there. So moment at C, MC, this is equal to RA into distance from A to C, that is L by 2. Direction RA, section is C, clockwise. Section is here is section, and if clockwise from left side, this is also clockwise from left side of this section will be taken as negative. Minus RA into L by 2. No load is there, so this is the moment at C, that is minus WL by 2 into L by 2, or moment at C is minus WL by 4. Now moment at D. Moment at D, we take the section at D. RA into distance from A to D, 3L by 4. Direction clockwise. Sign negative, because clockwise from left side of this section, clockwise negative. We take the negative. RA minus RA into 3L by 4 plus. Now there is one load is also there between A and D, that is W. So we will take it, we will take also it in the calculation, that W into distance from, we are taking the section at D. So the distance will be taken from W, that is acting at C, to D, that is L by 4. L by 4. W into L by 4, and this having the direction anti-clockwise. W is downward, so it will create anti-clockwise moment. This moment left side of section is anti-clockwise, then clockwise will be negative, anti-clockwise will be positive. So W into L by 4. Distance from C to D, C to D is L by 4. So we take distance L by 4. So moment at D is value, we have put the value of RA minus W by 2, 3L by 4 plus WL by 4. Finally we get the result by solving this equation. Moment at D is equal to minus WL by 8. Moment at D. And moment at B is 0. Moment at A is 0. So by taking the help of these values, we draw the bending moment diagram. Here MA is 0, AB is 0 line. We start from here. ME is WL by 4. We put the value, we draw a point here, and at C it is negative, so we are going downward. At C, moment at C, WL by 4. From WL by 4 we mark a point again here, and then MD minus WL by 4. We go upward at D, exact below this point D. Keep in your mind, the projections will come. D, WL by 8, and moment at B is 0, so we will put the point here at 0 line at B. Then we draw the line from A to E, E to C, C to D, and D to B. So here is, this is bending moment diagram, and the maximum value of bending moment is WL by 4, and this is negative. So we draw below this 0 line. If it is positive, then we will draw above this 0 line AB. This is bending moment diagram of a simply supported beam subjected to point load at its mid of this length L. Shear force diagram, bending moment diagram. This is a very simple problem. So I hope you have understood all these things, all these calculations, all these values, and all these diagrams. That's all. Thank you.